Hello everyone, I Rakesh Sir welcome you to the GATE 2023 Concept Capsule. Yes, these are the Concept Capsules where we bring upon some important concept relevant to the GATE examination in a short span of time to be completed. And yes, in this particular short Concept Capsule, I am going to talk about convolution, which itself is an important topic. And in this special video, we will focus on rectangular waveforms. How do you convolute rectangular waveforms? What is the tricks? What is the methods? All the things we are going to discuss in this session, understanding with the graphs and also understanding with the tricks. So let's get started, guys. To begin off, if somebody is new to me, this is a brief intro about myself. This is your mentor and educator Rakesh, and I have secured All India rank 9 in the GATE examination. Yes, I have secured All India rank 9th in the GATE examination and completed my masters from Indian Institute of Science, Bangalore. And yes, it's been more than 12 years having trained more than 50,000 students. These are my area of expertise. Okay guys, so let's get started. So before we discuss of the convolution of rectangular waveforms, just for a second let me make you revise the continuous time convolution integral. Right, the output of any LTI system having the impulse response ht is given by input xt convolution with the impulse response, where the convolution integral is given by the formula integral x tau h of t minus tau. Okay guys, right. So convolute the following waveforms. Now within the rectangle, although rectangular waveforms convolution is important for exam, but there also you have two different cases. Have a look into the durations of the waveform given to you. Have a look into the durations of the waveform given to you. Duration or width. What we are going to call it as duration or width of the waveform, and the duration here is equal to 2 units. The duration here is equal to the 2 units, and the duration of the second waveform is also equal to the 2 units in time. Okay, so basically the first case that you're looking into, that you have rectangular waveforms, you have rectangles of equal width. You have rectangles of equal width, right? Their amplitudes may not be equal. Here they are equal, but they may not be equal, but the width is equal, right? Now, as we know that the output of the LTI system is given by integral x tau h of t minus tau d tau, right? So, there are three different methods, right? Method number one. What is the method number one to solve this question? The method number one is solving this as area, because we know that integral of a function is also equal to area under the curve of this function. But which function? The area under x tau ht minus tau. So it should be area under x tau ht minus tau. That means since we are going area, that means we are going into the graphs. This is the graphical method of solving the convolution, right? Method number two is breaking the rectangle, right, into step functions. Breaking the rectangle into step functions, right? And method number three is the trick that I shall tell you at the end. It's a trick that I shall tell you at the end, very useful trick, and we'll tell you the trick for both, whether it is equal duration rectangle or unequal duration rectangle, right? So let us first understand the important graphical method. Is very good for understanding convolution integral, that is the area under x tau ht minus tau. So this is xt, right? I want to make it as x tau. Okay, so I have these waveforms once again. Let me just write down. So now I am going to treat it as x tau. Anyways, name does not matter. The function is the same, x, whether it is a function of t or tau. So x tau versus tau. But what is the second we need? ht is given to me. We need h of t minus tau. To generate h of t minus tau, dhyan dena. To generate the h of t minus tau, what should be the general procedure? H of t minus tau can be written as h of minus tau plus t. First of all, we are going to plot it on the tau axis. So h of minus tau plus t. Minus tau involves what? Basically, all must be knowing that minus tau is the mirror image, time folding, right? So this is a even symmetric function, right? From 0 to minus n and from 0 to 1, it's identical. The function on the left hand side and right hand side is identical. Its mirror images will be same. So when you take h minus tau or h minus t, It is going to be the same. Okay, so mirror image is not going to affect this function. Then after the mirror image, what is involved? Minus tau plus t. So there is a time shifting involved due to the t. So if the original coordinates were -1 and 1, after mirror image it remains as -1 and 1, right? But now you shift by t, so this should be -1 plus t. This should be -1 plus t. That means it's going to be, that means it's going to be, okay, t minus 1, -1 plus t, and this is 1 plus t. That I will write it as t plus 1. That I can write it as t plus 1. Okay guys, fine. The t minus 1 to t plus 1. Now, what is the area under the product? What is the area under x tau ht minus tau? Okay, so x tau is fixed from -1 to +1. But what about h tau or h of t minus tau? Okay, the duration, the starting time and ending time, it depends on the value of t. It depends on the value of t. So for different values of time, there will be different cases. And yes, before starting this recording, I thought let me do basic activities for you so that we'll focus more on understanding, and my writing time will be same. So that is why just before recording the class, I have written this for you. So now see, the first possibility is that the t plus 1 comes somewhere here. That means the h of t minus tau is somewhere before x tau, because t can be from -infinity to the infinity. So this ht minus tau is before the x tau rectangle, right? Are you getting this? Right. So okay, so in that case, this is how the picture will be. T plus 1 is less than -1. So what is the case I am referring here? T plus 1 is less than -1. So eventually t is less than -2. But in that case, both of them are non-overlapping, right? One of them ends and the next one starts. So there is no common value of time where they overlap and they can get multiplied. They cannot get multiplied, right? If one of them is 1, another is 0, another one 1, the first one is 0. So what is the area under x tau ht minus tau will be 0, right? Not only area, since there is no overlap, so here x of tau h of t minus tau itself is 0, and since the function is 0, the area under the curl will be 0. We will understand this through animation also. But now what I'm going to do, so this is time which went from -infinity to infinity. Now it is going to move forward, little forward, and it will cross -1. It will cross -1. But the lower end, t minus 1, it will not cross -1. So understanding, one of the end inside, one of them is outside. One of them is inside, one of them is outside. Okay, so the next picture will be something like this. See, t plus 1, this point, t plus 1 crosses -1, it comes inside, t minus 1 is outside, right? But now they overlap. So looking into this, I shall be able to say what is now the value of x tau ht minus tau, guys, right? So after the overlap, their overlapping is coming to be a rectangle, right? Their product will be coming to be a rectangle because both the values were 1. 1 into 1 is again a constant. Constant means flat line rectangle. And what is the base of the rectangle? So you are able to see x tau ht minus tau is equal to 1 into 1, which is 1, right? For this range, -1 to t plus 1, right? For -1 to t plus 1, right? So for -1 less than tau less than t plus 1. This is the tau axis, okay? But we are not interested in the value of x tau ht minus tau. We are interested in the area. So eventually it is a rectangle, and area under rectangle is height into base. What is the area under this rectangle? So that is the height into base. Height into base. So what is the height? Height is the flat 1. And what is the base? Base, you can subtract the base. How much is the base? T plus 1 minus 1 will become t plus 2, right? T plus 2. So this will be equal to t plus 2. The area under x tau ht minus tau will be t plus 2. But for what values of time? So as I told you, t plus 1 has crossed -1. T plus 1 is greater than -1. So t is greater than -2. But t minus 1 is still behind. Second wala cross nahi hua hai. So t minus 1 is less than -1. -1 cancel. T less than 0. So t greater than -2 but less than 0. So t is where? Between -2 se 0. So whenever time is between -2 se 0, Answer will be t plus 2. The convolution result will be t plus 2. Now next case can be what? Okay, just imagine that h of t minus tau is trying to run from minus infinity to infinity, and during its run, it's just crossing x tau. It's just crossing x tau, right? So next possibility is t plus 1 going even forward, right? And if the t plus 1 goes forward, t minus 1 will come inside. T minus 1 will come inside. Dhyan denge yahan pe, have a look into this, right? Able to see t plus 1 goes forward and t minus 1 is inside this yellow rectangle. It is inside the x tau, right? And now what you are able to see? What is the product x tau h t minus tau? So whenever they overlap, they multiply 1 into 1. What is both the values? 1 into 1. But for what value of tau? Right, t minus 1 to 1. For t minus 1 less than tau less than 1, right? But eventually what you need? You need the area, and since it is constant 1 means it's a flat curve, it's a rectangle. And what is the area of rectangle? So that is again height into base. Height is equal to 1 multiplied by base. What is the base? Have a look at this base. 1 minus, what is this base? 1 minus t minus 1. So 1 minus t plus 1, that will eventually become 2 minus t. So the convolution result will be 2 minus t for what values of time? Now let's again revisit. T plus 1 has crossed 1. T plus 1 greater than 1, so t is greater than 0. T minus 1 has come inside, but that is not crossed. So t minus 1 should be inside, less than 1. T minus 1 less than 1, so t is less than the 2. So eventually what I'm able to see, that t is greater than 0 but the t is less than 2, so t is between 0 to 2. So whenever t is between 0 to 2, the answer is 2 minus t. And the last case is t plus 1 is anyways running. T plus 1 runs more forward, but t minus 1 also now runs, and t minus 1 goes beyond 1. That means the complete rectangle ht minus tau will be outside. This is the case. T plus 1 greater than 1. Okay, sorry, the last point, t minus 1 greater than 1. So t, what about the t is greater than 2? Equal to nahin, t is greater than 2. Right, and again in that case, you are able to feel that there is no overlap. X tau ht minus tau is 0, and that is why the area under the curve will again be 0. So there will not be any area where t is greater than 0. Summarizing all these 4 cases, I have obtained that. Again, I have written this for you comfortably, right? Whenever t is less than minus 2, first case, or whenever t is greater than 2, the second case, yt is equal to the 0. Yt is equal to what? 0, right? That is the case number 1. This is the case number 4, the picture number 4, right? Whenever the t is between minus 2 to 0, we got the answer as t plus 2, right? You can relate with the case 2. And the next case 3 that we learned, whenever t is between 0 to 2, the result of convolution, the area under x tau ht minus tau is 2 minus t. And simply drawing up, there I will show you the neat diagram also. So whatever is the answer is starting from minus 2. Right, and minus 2, the answer is t plus 2, y equal to mx plus t. So slope is 1 and y-intercept is 2. Y-intercept has to be 2 and the slope has to be 1. Next, it is minus t plus 2, mx plus c. So m is minus 1, negative slope, but the y-intercept is yet 2. So yahin se start karenge, but with negative slope. And this answer should go up to the t equal to 2. Right. And beyond that, it's going to be 0. And before minus 2, it is 0. This slope is equal to minus 1. This is the neat and clear diagram. So whenever you get two rectangles of equal duration, you get a triangle. Right? Next case also we will learn convolution of two rectangles of equal duration. Convolution of two rectangles of equal duration produces a triangle. So see, this is what is the actual activity happening. One of the triangle, it was fixed, and another one is chasing it. Another one is running from the minus infinity to the plus infinity. And now let's have a relook. When this is running from the minus infinity to the infinity, see, it's increasing, and now earlier there was no overlapping. Have a look into this. It overlaps. When it is overlapping, the area increases, and as it passes, the common area is decreasing, right? So initially no area, right? Then the area, the common overlapping is increased, right? The common overlapping is maximum when the two rectangles just completely completely overlap each other, that is where you get the maximum triangle height. That is where you get this maxima, and after that the amplitude, the result of convolution, the yt is again decreasing. Why it is decreasing? Initially 0. Okay, initially 0, right? This is the area, this yellow area is increasing, the maximum overlap, and then again running, so overlap decreasing. And I hope this animation makes you the very story clear about the area under x tau, xt minus tau. That is how we convolute the two functions. This is the graphical method, right? And you know, by the similar method, you can, you know, convolute other signals like there's a rect and a right angle tripulse. Similarly, let's fix the x tau, h of t minus tau, h of t minus tau, h of minus tau. H of minus tau will just reverse this first of all. The h of minus tau will just reverse this first of all. Okay, and then h of t minus tau will do the time shifting, but time can be from minus infinity to infinity. So this inverted triangle will start running from minus infinity to infinity, right? Up to a certain point there will not be any area, and then the area is increasing parabolically and decreasing parabolically. Why parabolically? Because when we try to solve the function, right, one of them is 1, another one is t. See, ramp means t, na? I'm just explaining you this orally, then we will go to the next question. 1 into t. So what is the product of x tau, xt minus tau? 1 into t is t. What is the integration of t? Because we integrate x tau, ht minus tau. What is the integral of t? T square. T square by 2. So t square means parabolic. So this function will vary as a parabola, right? Now sir, let's move ahead. Okay, now what is the another method? Let me tell you alternate method, and then we will go to the trick. Alternate, as I told you, method number 2, breaking the rectangle into unit steps, right? So now this theory requires your knowledge of unit step and ramp. If you are clear, you can follow this method, or else you can first watch any video related to the sketching of step and ramp signals, right? Their slopes and their amplitudes, etc. But anyways, my main intent is making you go towards the trick, and we are going into it in a very short time. So rectangles can be broken as a difference of 2 unit steps. The first unit step starting from -1, right, and the second unit step starting from 1, right? Starting from -1, ut plus 1, left shifted step. Starting from 1, right shifted unit step, ut minus 1, and subtract both, right? And now this is now the whole procedure, right? We have the two rectangles of equal duration, similar rectangles we have, the ut plus 1 minus ut minus 1 convolution with itself, and then I have just used the result, unit step, convolution unit step is equal to ramp signal. So see guys, there is thousands of things inside convolution. Some of them are very important, and one of the important cases is rectangle. So in this short capsule, I am only covering rectangular convolution. So rest, you know, these are some properties which we can cover in another videos also. Step convolution step is a ramp signal. So I am using step convolution step equal to ramp along with time shifting property. We get this waveform rt plus 2 minus 2 rt plus rt minus 2, and after sketching of the ramps, we get this particular waveform rt plus 2, a ramp with unit slope, right, starting at t equal to -2, right, unit slope equal to 1. Then rt starts from origin, right, with slope -2. So already the slope is 1. Now the slope will become 1 minus 2, that is -1, so negative slope. So it will go up to next ramp rt minus 2, right shifted, starts at t equal to 2. How much slope? +1, right? So -1 already is there, +1 you get 0 slope. So after 2 you are running on the x-axis with 0 slope, right? So this is what I'm telling you. The main target is not talking about ramps. This you can learn you know, in any of my other videos also. Now let us come to the trick. Sir, what is the trick? Right, to solve this convolution, do I have to sketch it graphically? It will be time, it's very good for understanding, but at the exam time of view, it will be definitely little time taking, and we cannot you know, go ahead with that. So have a look into this. Right, I'll give you the direct shortcut. Two rectangles of equal duration d each, their amplitudes can be different, right? Whenever you convolute two rectangles of equal duration, the result is a triangle. We are very sure about this, right? What is that starting point of the triangle, right? The starting point of convolution is always the sum of the starting points of individual signal. So this is t1 plus t3. The ending point of convolution everywhere, not only rectangle convolution, but ending point of convolution is equal to sum of the individual ending points. So t2 plus t4. This is t2 plus t4, right? Then what else you need? You need the height. What else you need? You need the h, you need the height, and the height of the triangle is given by a1 a2 into the common duration. The duration is anyways equal, the product of amplitudes into the duration of the rectangles, a1 a2 into d. A1 A2 into D. Sir, convolute the following waveform. So answer is going to be now solved for you within 20 seconds. Right? Answer is now going to be solved for you within 20 seconds. Have a look into this. Have a look into this, and you get symmetric triangle always. Okay? Symmetric. Okay, symmetric about the center. So what is the sum of the starting points? Okay, this point is 0. So 0 plus minus 2. The triangle is going to start from minus 2. Ending points 3 plus 1. The triangle should be ending at 4. So what is the center? 4 minus 2 by 2, that is 1. This is going to be the symmetry point. Right? So just draw a triangle. Finish. But we should know the height of the triangle. Sir, what is the formula for height of the triangle? A1 A2. A1 into A2, the product of the amplitudes into the duration. So 3 into 2 into duration. See, duration is 3. Whether you take this one or whether you take this one, duration is 3. So I multiply 3 here. 3 2s are 6, 6 3s are 18. So this height should be equal to the 18. That's it. That's it. Very, very simple. This is known as very, very simple approach. Within 20 seconds, you can calculate all the values, you get the triangle. This is a simple shortcut, right? So guys, look into this example. The rectangle should be of equal duration. Their starting points can be different. One of them is starting from 0, one of them is starting from negative x-axis. One of them can be starting much ahead, another one can be much behind, but the duration, the total base should be the same, right? Okay guys. Now convolute the following waveform. You have unequal widths this time. Everybody try to see. You have unequal widths, right? The duration here is 2, and now I have given you a rectangle having duration 4. So you have unequal duration, unequal widths, and whenever you convolute rectangles of unequal widths, unequal duration, you get a trapezium. You get a trapezium. Right. So now we know the different methods of convolution, right? And I want to keep it as a concise short capsule. So for this one, let me give the direct trick. You have two rectangles of unequal duration, D1 and D2, where D1 does not equal to D2. When D1 does not equal to D2, the result is, in that case, the result is a trapezium, guys. Right, the result is a trapezium. Right, have a look at this trapezium. Have a look into this trapezium and have a look into this properties. So what is the starting point of the trapezium, sir? The starting point is the sum of the starting points. So this is T1 plus T3. The ending point of the trapezium is a sum of the ending points of individual signal. This is T2 plus T4. But what about this point and this point? So see, T1 is added with T3. So T1 plus T4, right? And T2 plus T3, right? Which of them is lower will come here. ये जो पॉइंट है ना, this is T1 added with T4, right? Or T2 added with T3. T2 added with T3, right? Starting and ending of the other one. Ending of first, starting of other. Which of them is lower will come first, which of them is higher will come second, right? Now, sir, what about this slope? What about this slope? So this slope is equal to product of the amplitude. That's it. This is a positive slope plus A1, A2. A1, A2 is the individual amplitudes, and this is just opposite to it. Minus A1, A2. Minus A1, A2. Right. So this is just minus A1, A2. Got it? Chalo. What about this height, sir? This we can calculate because we now know the slope. Let us try with the example, right? This is the question for, this was the already question for you. This was already the question, and before solving the question, I gave you the trick, right? This was the trick, and now what should be the answer? What should be the answer? Let me sketch in front of you. Again, within few seconds, minus 1, minus 2, the answer should be starting with minus 3. So again, within the few seconds, we are going to close the answer. The trapezium is going to start from the minus 1 plus minus 2, that is the minus 3. The trapezium should be starting from the minus 3. And trapezium will be ending at the 1 plus 2, that is 3, right? Now, dekho, minus 1 plus minus 2, that is minus 3, starting 1 plus 2, that is equal to the 3, that is ending, right? Now, minus 1, starting and ending of other, minus 1 plus 2 is plus 1, and 1 plus minus 2, 1 plus minus 2 is minus 1. So which of them is lower? Minus 1 will come first. So this is minus 1 and then plus 1 is here, right? So now just draw the trapezium. Minus 3 to minus 1, it's a ramp. Minus 1 to plus 1, it's a constant. And 1 to 3, it's again a ramp. What is the value of this slope? What is the value of this slope? It is the A1, A2, 1 into, let's take this also 1. There's nothing mentioned. So let me write down this magnitude as 1 also to be simple in the beginning. So this is equal to 1, sir. Why this is 1? This is 1 into 1 actually, right? And similarly, this slope is minus 1. Minus of 1 into 1. I told you that the another one will be minus A1, A2. That's it, right? Acha, if this slope is 1, what should be this height? What should be this height? To look into this. Height divided by base, base is 2, should be equal to the slope, so height is also equal to the 2. Slope was 1, so this height is also equal to 2. Okay, sir, one more, let's solve it in very quick time, guys. Okay, two rectangles of unequal width. This is having the duration of 4 and this is having the duration from 2 to 8 and that is a duration of 6. So definitely unequal. So let's say this is D1 and let's say this is the D2. Here I have D1 not equal to D2. So what is going to be my result? Here I have D1 not equal to D2. So what is going to be my result? Let's plot the result, guys, simply. What is the result? 0 plus 2, starting point is 2. 0 plus 2, starting point is 2. 4 plus 8, ending point is going to be somewhere 12. So isko thoda sa chota karna padega. Ending point is going to be somewhere 12, or let's make this x-axis little large. No issues with that also, guys. Right. So ending point is going to be 12. Starting point was 2. Now come to the intermediate points. Dekho, 0 plus 8. 0 plus 8. One of the point will be 8. This is 8. And 4 plus 2. Ending of first, starting of second. 4 plus 2 is 6. Okay. So this is one of the point. Now you have to have a starting line, increasing line, ramp line from up to 6. 6 to 8 it should be a constant. Right, and 8 to 12 it should be a declining line, a negative slope line. Right, what are the slopes, sir? So this slope is equal to how much? Product of the amplitudes 2 and 4. Right, 2 multiplied by 4 is 8. So this is the slope equal to 8. Right, so this slope will be minus 8. How much is this height? How much is this height? So height divided by base of this section. Height divided by base of this section. Base kitna hua? 4. Right, is equal to 8, and hence the height is equal to 32. Hence the height is equal to 32. Right. Previous case also height divided by base. Base was equal to 2. Correct. Right. Yeah. So height and divided by 4 is equal to 8. So height is equal to 32. Very quickly solved. Right. Since I'm describing you, it may be taking a little more time, but for you actually hands-on, when I solve it for me, it will be taking few seconds only, probably 20-30 seconds, right? So guys, in this short capsule, I've tried to cover convolution of rectangles, right? Of unequal widths, it is a trapezium, right? Unequal widths, the result is trapezium. If the widths are equal, then the result is a triangle. Hope you have liked this video and hope you have learned some concept. Hope this capsule helps you in learning one of the concept, and we'll keep bringing you more capsules every week, right? And if there is any more specific concepts in your mind that you want me or the BYJU'S Exam Prep team to address, do not forget to mention that in the comment box, right? After watching this video, please do mention in the comment box how beautifully you learned this concept, whether you enjoyed or not, and also mention in the comment box any more concepts, short concepts important for GATE you want us to address. We'll address it definitely, right? And if you're really learning and if you want more such videos, do not forget to subscribe the BYJU'S Exam Prep GATE ECE English YouTube channel. Bye bye, thank you, stay safe and take care of yourself.